December Solstice Sunrise Sunset Azimuths, an armchair exploration of two random world cities featuring a prediction spreadsheet based on high school geometry. This is a sort of like a live recording. I'm just recording this without a script, and I wanted to include the clock up here in the corner, so it's 11:20 p.m. as I'm starting this. And what I'm going to do is I'm going to basically go to a random city generator, randomlist.com. It's got a random city picker, and we'll pick two world cities, one in the Northern Hemisphere, one in the Southern Hemisphere. And then we'll start using SunCalc.org to find the sunrise sunset data for those cities. Though it's like an armchair exploration. Then I'm going to put them into my my spreadsheet that I created just using high school geometry. So I just did a little analysis of the globe Earth. I mean, just knowing what I know about like circles, and a little bit of trig, and also with the flat Earth map. I was just using the Gleason's map because that's the one that most folks like. But you're welcome to do an analysis using a different map if you like, because you could just use trigonometry. And so let me first start by reviewing just very, very quickly. This is a video I created, I guess, 7 years ago, right? December 2016, 7 years ago. And it was on, Azimuth of Sunrise, Sunset. And this is one of these explorations that you can do out in the field. And so let me just scroll through. And so I do have a little bit of trigonometry in here, but basically what it was based on is, you plan your observation, you plan, when the sunrise and sunset is, and then you go outside, you make a careful observation, knowing, what you know about azimuths, and, you may need to, put a ruler up against a curb, if you know that curb is a certain angle. So there's various ways of recording azimuth if you don't have a theodolite, if you're not a trained surveyor. But then what I did is I took the Gleason's map, and I kind of planned out like what would happen if, basically in terms of sunrise and sunset. So if you have a full circle in 24 hours, and on the December solstice, the sun is above the Tropic of Capricorn, right? So if you have a 24-hour circle, then knowing the time of sunrise and sunset, then you can kind of pick like sort of a subset of that, right? So if you know there's so many hours of sunrise in wherever you live in the world, right? The Northern Hemisphere has winter in December. So we have fewer hours of sunrise. So out of the 24, then you can kind of pick, where that would be. Also knowing the sun is above the Tropic of Capricorn. All right. And then so you just do a little bit of trigonometry with that. So here you can, make a triangle, do some trig. And then I put that into a little spreadsheet. So all you need is your latitude, what hemisphere you're in, and then a time of your sunrise and a time of your sunset. So if you type those things in, it will then make the prediction based on the flat Earth model. Okay. Then I did the whole thing with the globe. So with the globe, you've got the December solstice. So that's the sun is 23.5 degrees south of the celestial equator. All right. So, and again, I'm going to use a little bit of trig. I'm just going to use a little bit of high school geometry to kind of plan things out. 90 minus your latitude, yada, yada, yada. And then I kind of alternate between side view, and then I put a triangle in here. Where's the triangle? There we go. Whoops. There's a triangle, right? And then I figure out some math with that. And then I switch to a top view. All right. And then I also draw some triangles. So again, the sun should be rising south of due east. So again, this is a top-down view where north is to the left and south is to the right. So then I can do an analysis of that triangle using a little bit of trigonometry. So the bottom line is, then here's that sunrise, sunset. So for example, in the Northern Hemisphere, where we have fewer hours, right, fewer hours of sunrise, then the sun should rise south of east and then set south of west, and then sun should be up in the sky for a certain number of hours. So I basically my little spreadsheet just automatically predicts, again, based on your latitude, it will predict the globe Earth and the flat Earth sunrise and sunset. All right, so basically that's the spreadsheet. I put the whole thing together. I kind of changed it around a little bit. Here's what the spreadsheet looks like now. I just kind of put the instructions at the top and kind of move things around. And then I also added a sunrise sunset error analysis based upon actual observations. And what we're going to do in our armchair exploration is we're going to get these numbers from SunCalc. All right. So that's an introduction. So what we're going to do now is we're going to go to random lists. And again, just so you don't think I'm like stacking the deck with, I'm picking out a certain city. What I'm going to do is I'm going to go to the website and then I'm going to immediately hit rerun. So it's like burning one and hold them. Then I'm going to take note of the very first city of the Northern Hemisphere, because most of them are in the Northern Hemisphere in the database. And then I'm just going to keep hitting, rerun. So I'm going to get the first Northern Hemisphere city, and then the first and the second Southern Hemisphere city. So I'm just going to keep hitting rerun until I get, one north and then two south. And then what I'll do is I'll see which of the Southern Hemisphere cities is further south, because I think you get some really interesting results. So I'm going to click on that link now. It says open link. All right, so it starts off at San Diego. I'm just going to hit rerun. That burns one. Okay, so the first Northern Hemisphere city is Fukuoka, Japan. Okay, so I will have that be my Northern Hemisphere city. Now I'm just going to keep hitting rerun until I get two Southern Hemisphere cities. All right, okay. EKURHELENI, South Africa. Okay, that's pretty far south. I don't know which exactly how far. Okay, and then Lima, Peru. Lima, Peru is much further north than South Africa. So we now have our two cities, Fukuoka, Japan, and EK, South Africa. I'm not gonna pronounce that. So we're gonna now go to SunCalc, and let's type in Fukuoka, Japan, and there it is. And we're going to put in 21st December 2023. That's the December solstice. All right, so if we whoops, didn't mean to scroll it that far. Oops, I think I clicked. All right, I have to go back. I clicked somewhere. Fukuoka. All right, the SunCalc does not like when you click. So when you click on things, it like zooms into that location. So let me see if I can, because I'm like all the way down on the screen. Well, I think you guys can see this a little bit. I the way I've got my screen set up, my screen share set up, is I'm stuck in the bottom of the screen. So, all right, but we do have the information over here on the left. So one of the things that you could do is you can literally click on sunrise, and then it will give you the azimuth of sunrise. So let me bring in my my spreadsheet, and I'm just going to move my spreadsheet over so that I can see the. Let me move it over here. As you can tell, I'm doing this live. Whoops, what just happened? Oh, it's not capturing it. All right. So I'm just going to try to type in the time and the date. I'm sorry, the time and the azimuths. So sunrise is at 7:18. Hopefully this isn't going to be like watching paint dry. And sunset is at 17:14 or 5:14. So 17:14, and then so my my spreadsheet recognizes 24-hour time. And what is my latitude? I think I'm going to need to shift this down. What is my latitude? It does say here. Okay, and I'm just going to copy and paste it so I don't have to painfully type it in. So my latitude is, and we'll do paste values only so it doesn't mess up the green. And this is a north latitude. Okay, 33.5 degrees north latitude, sunrise 7:18, sunset about 5:14 p.m. Now, since this is an armchair exploration, what I'm going to do is at sunrise, I'm going to get the azimuth. So it says the azimuth is 117.85. Okay, so 117.85 degrees. And it says if you click on sunset, click, it says the azimuth is 242.15. All right, 242.15. 242.15. Okay, so now the spreadsheet is going to do its thing. Now, again, this thing is the blue cells are optional, so I'm only putting in the observed for purpose of comparison. So the only thing you're required is azimuth and time of sunrise and sunset. That's the only thing the spreadsheet needs. And then so if we scroll down, let me kind of change my orientation here. If you scroll down, you see there's a bunch of calculations, a bunch of intermediate calculations here. And these calculations are copied from that the video that I made. So the calculations for the globe, and the calculations for the A projection on flat Earth, so these things aren't really going to make much sense to you. The R, the D, the T, the phi, that's not going to make much sense unless you're referring back to the video where I've got the diagram. But here is the prediction. The prediction is that on the globe Earth, the sun will rise at 118 degrees east by southeast and set at 242 degrees west by southwest. But on the flat Earth, it would rise 77 degrees east northeast and 283 degrees. Now, because we actually did the armchair exploration, we just used SunCalc to actually record, what SunCalc is saying the sunrise angle and the sunset angle are. We can now look at the error. So you can compare, what kind of an error we got with the globe Earth prediction. And again, this globe Earth prediction is just using high school geometry. And then the flat Earth prediction as well, also using high school geometry. All right, so let's take a look at our next city. And our next city was EK. I'm going to say EKURHELENI. And that is in South Africa. So, okay, ZAF, I'm not sure if that's... So let me zoom out. Let's just see if it does look like we are in... All right, so we're right outside Johannesburg. Okay, so this looks like this is the correct place. So first thing I want to do is I want to grab my latitude. And it says the latitude is -26. All right, so on my spreadsheet, you have to actually do a selector of north-south. So I'm gonna copy the latitude, and I'm going to paste. Whoops. How am I going to do this? I'm going to delete that, and then I'm going to right-click. It says paste and match style. What's going on here? How come it's doing paste special here? I don't know why it was doing that. Paste values only, because I don't want it to mess up the green highlighting. Okay, so that's 26 degrees south latitude, And then sunrise is at 5:11. In fact, let me just delete all these. Sunrise is at 5:11, and again, I hope this isn't like watching paint dry, watching me painstakingly type in these values. Sunset is at 18:58 or 18:59 if you round it. 18:59, so that's 6:59 p.m. Then, again, since this is an armchair exploration, I'm going to click on sunrise, and that's going to give me the azimuth. And the azimuth is 116.78 degrees. And I guess I can have this moved over so you can see observed. It's called observed azimuth of sunrise, observed azimuth of sunset. And now I click on the indicator for some sunset, and it says 243.21 degrees azimuth. And I'm just going to paste that as well. Okay. So again, we are going to have the spreadsheet do its thing. And again, it shows all the intermediate calculations, and it predicts that on the globe, again, just using the latitude. So if you look at the globe prediction, just using latitude, using latitude and sunrise and sunset, it predicts 116 degrees east southeast, and then 244 degrees west southwest, which is quite different from the flat Earth prediction. All right, and then you take a look at the errors, and the globe error is there, and then the flat Earth error is there. Okay. Now, one thing I would like to do is go a little bit further with this, and let me just have this thing rejoin. I'm going to actually go to the Walter Bislins Flat Earth Dome model. Okay, Walter Bislin. And I'll put a link in the description. And so what I'm going to do is we are going to pick the latitude and longitude of the South Africa town, which is right outside of Johannesburg. So I'm going to pick, I guess it might still be in the memory, but so this is the latitude, and let's put this in for the latitude, and I will put a minus sign in front. Okay, so there's the latitude, and then let's do the longitude again from SunCalc. So that's about 28.2 degrees longitude, and this simply puts an observer at a location. Now the thing is, the camera direction, I want the camera to be pointing north south, so I'm going to put the same thing for I'm going to put the same thing for the longitude, so that the camera lines up so that on the map, north south for that town in South Africa is perfectly aligned on the map. Now, if we adjust the time, so you can see that we're still on December 21, but this says 2017. I did look it up. The December solstice in 2017 is on December 21st. So, because the year, cycles. But then you can kind of see where the sun is. So this is, South Africa is in nighttime, and so now we're approaching sunrise, and then now the sun has risen. Okay. In fact, the sun is only half a degree above the horizon. In fact, if I could play with this a little bit, at 3:22. The sun is not visible, but at 3:35 it is visible. So 3.35. So let's just play with this a little bit. How about 28? Let's try that. Sun not visible. How about 3.3? Sun is not visible. How about 3.4? All right, the sun is now visible. Okay, with an elevation of 1 degree above the horizon. So the azimuth, I don't know if you can see this up here in the upper right-hand corner, The azimuth is 115 degrees, 0.7. That's the globe. Oh, I'm sorry. That's the globe, not this thing up here. The globe sun is down here. So let's see how that compares to my globe, my sunrise prediction. My prediction was 116 degrees, and this says 115.7, which rounds to 116 degrees. Now, I'm going to do something really quickly. I want to just compare the flat Earth model. So the globe, the globe prediction matches the globe prediction. So that's if the sun were actually due, or southeast of South Africa. But what I want to do is I'm going to take a screenshot of this, and I don't have any sophisticated tools, and I just kind of grok stuff out using Keynote. I mean, you'd be really appalled if you found all the stuff I did with Keynote. Let me just delete some of this other stuff. So what I'm going to do is I'm going to use this rectangle, and let me just paste in this image that I just captured, and let me use this. And this is just a generic black rectangle. Whoops, let me put this. I'm going to send this to the back. Okay, so what I'm going to try to do is I'm just going to try to connect, and I need to use some formatting and arrangement. Okay, so I'm just going to try to move this rectangle around. And the thing about this rectangle is it's 180 degrees is due north-south, and then it counts down from there. Another way of saying that is we're counting clockwise from 0. So clockwise from 0. And then I'm just going to try to line these things up. That's actually pretty good right there. I'm just going to try to get the angle. Oh, that's almost perfect. All right, so it's 140. It's 140 degrees clockwise, which is I'm trying to do the math in my head. It's 140 degrees clockwise. So we're gonna take the complement of that, which is 40, or it's actually 39.5. So 39.5 is my estimate. 39.5 degree azimuth is my estimate of the flat Earth sun. Okay, I don't know if that made any sense at all. So let me take a look at what my spreadsheet predicted, and my spreadsheet predicted that the sunrise would be at 38 degrees. Okay, so Walter Bislin, and then me just drawing lines on a map, 38 degrees, I predicted 39.5. Or I'm sorry, I predicted 38, and then he's predicting 39.5. Let's see what that, oops. Oh my goodness. I'm going to check, okay. I'm just trying to increase the, there we go. There we go. I don't need that many decimals. So 37.7. Okay, so that rounded up to 38. So I'm a couple degrees off from the Walter Bislin demonstration. But I hope that was enough of a little demonstration for you guys. Again, let's take a look at the time. It's now 11:44 p.m. So this was done in real time without a script. So hopefully you got a little bit out of that, and happy December solstice, everybody. Goodbye.